Transformers. Yes, an inductive load. Transformers do come in many shapes and sizes, from board-level components to industrial sizes. As mentioned earlier, they are part of how electricity is delivered to us. Transformers typically step voltage up or step voltage down, with the exception of an isolation transformer that is used to protect sensitive electronic equipment. The way a transformer works is when current starts to flow through the winding on the primary side, it creates a magnetic field. That magnetic field causes the electrons on the secondary side to react and start to move. This creates a voltage difference on the secondary. The voltage difference completely depends on the amount of turns in the wire. We're not covering how to make a transformer, so let's leave it right there. It's important to read the transformer voltage taps to ensure we apply the correct voltage and create the correct voltage. You can have multiple taps on both the primary and secondary for multiple voltages. The alternating current in a transformer is what helps create its resistance. But in inductive loads, where we are inducing work using a magnetic field, the resistance is called impedance. Again, the fluctuating magnetic field is what impedes the flow of current. The wire itself does have some resistance, but the real resistance is the magnetic field that is created because the magnetic field is constantly changing, causing back pressure as the magnetic field pulsates. When you create a magnetic field, the magnetic field wants to move the electrons even as it shrinks. Another thing to point out is transformers only work in AC circuits because of the constant change in polarity and the voltage fluctuation. To test one, with your meter on the ohm scale, you simply look for continuity in an individual winding. If you read any continuity to ground or its core, you have a shorted coil. If you read any continuity from the primary to the secondary, you have a shorted coil. If you read infinite on an individual winding, the coil is open and bad. The primary and secondary do not electrically touch each other, so you should read infinite or open line if you read the primary to the secondary. We will not be able to use simple math to determine if it's correct without having a lot of data from the manufacturer. So the easiest way to check it is, do I have the correct input voltage and do I have the correct output voltage? Use your meter on the volt scale to test. Transformers typically do not fail on their own. Failure usually lies in incorrect input voltage or something on the secondary side shorted out, causing a high current flow through the secondary side of the transformer. If you have a failed transformer, look for the cause. The problem was not in the transformer. The only other reason a transformer would fail is exposure to high heat that melted the winding insulation, causing it to short to the iron core. If your transformer failed, replace it with a new transformer. However, troubleshoot to find out why it failed. Many techs will put fuses in line with components to see which fuse blows, thus helping isolate the failure and not having to replace the transformer again and again. If you keep replacing the transformer, your customer will lose faith in you. To select the correct fuse for a transformer, look at the VA rating. This is the same as wattage. An example, a 100 VA 240 volt primary with a 24 volt secondary. For the primary, you will do 100 divided by 240 equals 0.416 plus 1.25% equals 0.421 amps. You go to the next highest fuse, which is a half amp fuse for the primary. For the secondary side, you will do 100 VA divided by 24 equals 4.16 plus 1.25% equals 4.1 amps. The secondary should be downsized to the next lowest fuse, a 4 amp fuse for the secondary.